So in today's lesson, we are simply going to focus on solving for x in exponential equations. And these ones are a little bit advanced compared to the ones that you did in grade 10, because now we'll be factorizing as well as solving for x in quadratic exponential equations. Imagine. So let's say you are seated peacefully in the exam, minding your own business, and they decide to ask you to please solve for x in this case. So we have 2 times 3 to the x, which is set equal to 81 minus 3 to the x, all right? Now, looking on the left-hand side of this equation, we can see that we have one term. But if we look at the right-hand side, we actually have two terms because we know that terms are separated by either a plus or a minus sign. But now, furthermore, we realize that 2 times 3 to the x, as well as the 3 to the x there, they're actually like terms. The coefficient of 3 to the x on the left-hand side is 2, and the coefficient of 3 to the x on the right is actually 1. So what we are going to do is to take this one to the left-hand side so that we have 2 times 3 to the x plus 1 times 3 to the x, in which case we simply get 3 times 3 to the x, and this is equal to 81, all right? Now, at this step, you can actually proceed in one of two ways. The first way, you can choose to divide both sides by the 3 because it's disturbing us. So then, after successfully dividing both sides by 3, well, 81 divided by 3 is simply going to give us 27. And now we can write 27 in exponential form to base 3 because we know that when the bases are the same, well, the exponents are bound to be equal as well. So this is what we can say. But then, if you didn't want to divide both sides by 3, then you could have decided to say the exponent of 3 is 1 and say when multiplying powers of the same bases, we simply add the exponents. So then you have 3 to the power x plus 1 here, and you say this is equal to what? Well, 81 can be written in exponential form to base 3, and it is simply 3 to the power 4 like that. And once again, you say, well, if the bases are the same, then it means the exponents must be the same as well. And of course, when you take this one to the right, it becomes negative. And you find that the value of x is simply going to be 3. So you can actually decide whether you want to do it using the first approach or you can do the second approach. Any of those two are equally correct. All right. But now, what about in this case? Let's say they give you 2 to the power x plus 2. And here we have plus 2 to the power x minus 2. And then we have 2 to the power x. And everything is set equal to 42. Well, the first thing that you realize here is the fact that each of these terms has a 2 to the x in it. But then what is the problem? The problem is in the first two terms, the 2 to the x is not readily available because of the plus 2 as well as the minus 2 there. So the first thing that we need to do is to break this up. That's what my learner used to say. But actually, I like to say we reverse the first law of exponents to say before we added the exponents, we were once multiplying powers of the same basis. But you can still say you are breaking it up. That's perfectly fine. But I just like to use the correct mathematical language. Yes. And here, well, x minus 2, of course, we know that it's exactly the same as x plus, and then you say minus 2. So it's still the same situation. Before we subtracted those two exponents there, well, we actually had something like this one. Or you can say we actually had something like this one. Well, both of us are equally correct because in the actual sense, you are subtracting, and according to the second law of exponents, when dividing powers of the same basis, you take one base and you subtract the exponents. So you'll decide whether you want to reverse it like this or you want to reverse it like that. All right? Okay. Then, of course, we still have our 2 to the x, and everything is set equal to 42. So now we can see that, well, this is actually one term, and one term. So we have 3 terms on the left-hand side. And on all of these 3 terms, we now have 2 to the x in common. It's now readily available, so we can now access it. So now we come and we take it out as the highest common factor. And when we take it out, from the first term, we are left with 2 squared, which I'm going to write as 4. From the second term, we are left with 2 to the negative 2, which is the same as 1 over 2 squared. So it's just the quarter. And from this one, we are left with 1. And this is very important. Many learners, they tend to say 0, or they just forget about this altogether and only say something like this. No, that is incorrect. So please make sure that you do proper mathematics. Because if you reverse this, 2 to the x times 1, that is 2 to the x. All right? Then you close your bracket, of course, and you equate everything to 42. So now it's time to simplify what is inside the bracket. We still have 2 to the x there. If you now go to your nice calculator and say 4 plus 1 over 4 plus 1, well, you simply get 24. Well, actually, it's 21 over 4. Sorry about that. And this is divided by 4. And everything is equal to 42. Then what do you do from this stage? You divide both sides by 21 over 4, or you can multiply by the reciprocal of 21 over 4, which is just 4 over 21. So then, on the left-hand side, you're left with 2 to the x. What about on the right? Well, on the right, you have 42, which is multiplied by 4 divided by 21, and you simply get a beautiful 8. Well, mine was rather ugly. Then now it's time for you to write this 8 in exponential form to base 2. And now you can say, when the bases are the same, we equate the exponents. And remember the most important thing. when you are dealing with equations, it's really possible for you to walk out of the exam room knowing whether you killed it or it killed you. Because always check whether your left-hand side is equal to the right-hand side. Take this x value and substitute it there and see if the answer will give you 42. Right. So I think we can fairly agree that the first two problems were a little bit of a walk in a park, if we can say. So let's talk about the quadratic exponential equations. Now, what do I mean by this? Well, I think there's actually another video on exponential equations on my YouTube channel. So please do search it up. It also has a few examples of exponential equations, quadratic exponential equations, that is to say. Now, let's say they give you 2 to the x minus 2 to the x plus 2, and then we say minus 32, and this is equal to 0. So the question is, how do you solve this? Well, first things first, the problem when looking at the first term is the fact that x has a coefficient of 2, but here x has a coefficient of 1. So every time you see x having a coefficient of 2, then you must know that it's a quadratic exponential equation. But then you have to write it in a way so that it looks like an exponential or rather a quadratic equation. How do you do that? Well, 2 to the power 2x is exactly the same as 2 to the power x, but then you say this is all squared. Because when you multiply those two exponents together, you still get a 2x. You haven't changed anything. Now, when we come to this middle term, we are going to break it down, or rather we reverse the first law of exponents. So then we have 2 to the x there, and then we say times 2 squared, and then we say minus 32, and this is equal to 0. But to write it even nicer, we can just say, well, yes, it's still 2 to the x, which is all squared. Then we say, well, this one is just going to be a 4. So we can take the 4 and put it there. And then we have 2 to the x. And then we have 32. And this is equal to 0. But if you want it to make perfect sense that it is indeed an exponential equation, you can make use of the K substitution method. The whole point of using the K substitution method, it is actually to simplify this equation. So here we are simply going to allow 2 to the power x to be k, so that 2 to the power x, which is all squared, is now going to become k squared. And when we see this, we see k, and now we have our 32. Can you see it's now a normal exponential equation? But then it's not compulsory for you to use the K substitution method. You could have decided to simplify this step by using the normal factorization. Not really. I didn't want to say simplify. I wanted to say you could have decided to factorize this step by using the normal quadratic factorization of opening two brackets. But then this is how it becomes easy if you're using the K substitution method. You now say factors of k squared, that is k and k, and factors of 32, that add up to 4. Well, which ones are those? 32 can be written as 16 times 2, doesn't add up to 4. But then you can also write it as 8 times 4. And the bigger number takes the sign of the middle term. So this is what you can say. But if you didn't use the k substitution method, you just had this and you want to factorize this, then you could have decided to open your two brackets and then say this is equal to 0. Then you say, what are factors of 2 to the x, which is all squared? That's going to be 2 to the x as well as 2 to the x. And then you say, well, factors of 32 will be 8 and 4. And once again, you'll have this, and then you will have that. All right? Yes. But then, assuming that you're proceeding with the k substitution method, then this is what you're going to say. Then you remember, what is k? Well, k is actually 2 to the x, right? You don't even need to say but. You can just say, well, 2 to the x equals 8, or 2 to the x equals -4. Is this possible anyway? No, it's not possible. Why? Well, for the simple reason, 2 to the x is an exponential equation, or a function that is increasing. It's an increasing function, and it's always above the x-axis. So it can never be negative. That's why we say, no, that's not possible. Right, and then of course, this 8, you can just write it as 2 cubed, and the value of x will simply be a beautiful 3, like that. Yes. But then if you didn't use the k substitution method, then what is going to happen? Well, it means you are not going to have this part on your solution, right? No, it's not going to be there, as well as this one. So the blue parts are not going to be there. But then if you're using the k substitution method, then this pink part is not going to be there. So that is the difference between those two. I strongly recommend you use the k substitution method. It makes life relatively easy. Yes, it really does. Well, let's look at another one that should really challenge you. And remember, in order to get the most out of this lesson, you're more than allowed to pause this recording and quickly solve the problem. And then you can, I don't know, what do you do? Yeah, you pause. Maybe you proceed the video. I think so. And then you can watch the rest of the solution. Of course, that's if it showed you flames. Okay. So here we have 3 to the power 2x plus 1 minus 4 times 3 to the power x. And this is set equal to -1. Now, once again, we see that x has a coefficient of 2, but here x has a coefficient of 1. But I want you to realize something. If the coefficient was 2 on both of these terms, then it's not a quadratic exponential equation. You are just going to solve it in the same way as this one, because the coefficients are the same. You only say it's a quadratic one if one of them has a coefficient of 2. Very important. All right. Now, first things first, we are going to reverse the first law of exponents. So we say we have 3 to the power 2x times 3 to the power 1, or you can just write it as 3. And here you have 4 times 3 to the x, which is set equal to -1. And then you say, well, if I write this in a nice exponential way, then I can just say, okay, fine. I'm going to take the 3 and bring it to the front. And then I'm going to say, well, 3 to the power 2x is exactly the same as having 3 to the x, which is all squared. And I still have this thing. But then I'm just going to take this one to the left-hand side, and it becomes positive like that. Then I tell them that I'm going to use the k substitution method. So I allow k to be 3 to the x. Of course, you don't write this aside. You have to write it directly below there. So the reason why I'm writing it there is just due to space. I want to maximize the space that I have here. So then this means we now have 3k squared, and here we have 4k, and then here we have plus 1, and this is equal to 0. I think this is an ugly k. Right, much better. Now, we then realize that this is actually an advanced quadratic equation, and I showed you how to cheat the advanced quadratic equation by making use of the quadratic formula, but without actually showing the quadratic formula here because we need the factors. All right. So yes, please search the video on quadratic equations here on my YouTube channel, and you can gladly watch it and see how to cheat. Well, you're not really cheating. Well, it's for people who find it difficult to factorize advanced quadratic equations. Yes. Well, factors of 3k squared, that will be 3k and 3k. And then factors of 1, that will be 1 and 1. And both of them will have to be negative. I made a mistake here. Sorry about that. It's just supposed to be a k. Yes, did I say factors of 3k squared? It's 3k and 3k. Yeah, no, I'm getting old. Please forgive me for that. I wanted to say 3k and k. Sorry about that. Well then, it means 3k minus 1 equals 0, which means that k is a third, or k is actually 1. Then we remember what is k. K is 3 to the x. And a third, 1 over 3 is the same as 3 to the -1, which means that x will be -1 or x will be 0. Because we know that if we have 3 to the power x, which is equal to 1, we have to use the fact that any number to the power 0 is 1. And now we can gladly say x equals 0. All right. But then we need to check these two values. Are they both correct? Well, I'm going to begin by substituting -1. Yes, so I have 3 to the power 2 into negative 1 plus 1 minus 4 into 3 to the negative 1. Yes, that one is correct. What about when x is 0? Well, that is correct as well. So both of them are equally correct. Now, this one is actually an exception. It's not really an exponential equation. It's just a question that I wanted to throw in. Yes, there's also a video on my YouTube channel for equations involving rational exponents. So let's say they ask you to please solve for x in this case. We have x minus 7 times the square root of x, which is equal to negative 12. Well, you can actually do this problem in one of two ways. By first saying the square root of x is the same as x to the half. And then you can take this 12 to the left-hand side and listen to what you're now saying. You say, okay, fine. I know that the exponent of x is 1. That's what I know. But then one thing I know about 1 is the fact that it does relate to a half. How does it relate? 2 times half is just going to be 1. But now that you see this relationship, it means you can write x to the power 1 as x to the power half, which is further squared. You want to generate a quadratic equation. Do you see that? Yes, this is what we are saying. So then we can now use the k substitution method. We let k to be x to the half. Remember to write that. Show them that. But I'm not going to show it here. So now we have k squared minus 7k, and then we say 12, and this is set equal to 0, like that. Then we can now say, well, factors of k squared, that's k and k, factors of 12 that add up to 7, and both of them must be negative so that the product is positive. That can only be 4 and 3. And of course, this is what we are saying. So k will be equal to 3, or k will be equal to 4. But what is k? Well, k is actually x to the half, which is equal to 3, or x to the half is equal to 4. Then in order to solve for x, we just need to square on both sides, all right? Yes. And after successfully squaring on both sides, then it means x will just be 3 squared, which is 9, or x will be 4 squared, which is 16. But then remember, always check your values to see if both of them are acceptable, especially in cases where you have roots. So let's begin with 9. We have 9 minus 7 times the square root of 9, and that is indeed equal to negative 12. What about 16? Yes, that is also equal to negative 12. So both of them are correct, all right? Now, what is the second way in which you could have done this? Well, you could have taken or rather treated this question as a problem under equations involving root equations or rather root signs. I don't know. But we do have that video. I recently uploaded it on my channel. It's called Root Equations. So you can go to that and look at how this should be done. But just to give you a feel, this is what we do. So we are simply going to take this one to the left-hand side, and we take this one to the right-hand side. We want to isolate our root sign, all right? So then we get x plus 12, which is equal to 7 square root x. And then we square on both sides. And after successfully using the FOIL method in order to expand here, we simply get x squared plus 24x plus 144. And this is equal to what? 7 squared, that is 49. And of course, the square root of x, which is squared, that will give us an x. Then we take this one to the left-hand side. We still have x squared. But now we say 24 minus 49. And we simply get negative 25x. And of course, this is added to 144. And it's set equal to 0. Then it's now time for us to factorize this. So what are factors of 44 that add up to 25? Well, they're simply going to be, if you determine this into your calculator by saying 144 equals, and then saying shift and then pressing that button that has many dots under fact if you're using a Casio, then you're going to get 2 to the power 4, which is 16, and 3 squared, which is 9. And of course, both of them have to be negative, and it's still the same values that we got here. So if you want more on root equations, then of course you can quickly search that video on my channel and your happiness will be complete. Well, thank you so much everyone for watching. I really hope you learned a lot in this lesson on exponential equations.